So this is another lecture in vectors, and we are taking a question from the first exercise. Till the last lecture, we had been doing the concepts of basics of vectors and related concepts. Now we are we are in a position to solve few problems. So let us start with the first exercise. This is question number 11. I may not be taking the questions in order. Uh, I will take the questions randomly as per the uh, based on the concepts that we have learned. So I'm taking some important questions based on some important concepts first, and then gradually we will go ahead and we will take up all the problems. So here question number 11 is, show that the following points are collinear. Okay, there are two questions. One problem I will solve, and the second one you can try on your own. So here the question is, show that the following points are collinear. So there are 3 points given and we have to show that these 3 points are collinear. Now you all understand the meaning of collinear points. Okay, which points are said to be collinear? See, this is one line, and if I have points lying on the same line, then these points are called as collinear points. Suppose this is A, this point is B and C, then A, B, C are collinear points. But if I have A, B here and think I have a point here D, I have a point here D. Now A, B, D are not collinear. Why? They are not collinear because if I join, if I join, if I join D with B, if I join D with B, C, then I notice that point A is not lying on that line. Okay, see DB, where is A? A is on another line. Or when you join A with B, you find that D is on some other line only. Okay, so A, B, D, they are not collinear. The 3 points are not lying on one single line, but A, B, C are collinear points. Okay, very good. So we have to prove that these 3 points A, B, C are collinear. See, how will I solve? I will first find, I'm solving the first one. I will solve the first one. What I will do is, from the given 3 points, I shall find out the position vector of these 3 points. So I write here, okay, from given points, we can write what you could write. You will write A bar equals to 3I cap plus 2J cap minus 4K cap. Then you will write B bar equals to 9I cap plus 8J cap minus 10K cap, and C bar equals to minus 2I cap minus 3J cap plus K cap. Okay, so we got A bar, B bar and C bar. What I will do next is I will find out the displacement vectors. Which displacement vectors I will find out? That is, I will find out AB bar. See, I have 3 points. I have 3 points here, and I got their position vectors. Okay, so what I shall now be finding, I will find out AB bar and BC bar. So first of all, I would like to explain you that you having found the A bar, B bar and C bar, what have you actually found? After having found A bar, B bar, C bar, after finding A bar, B bar, C bar, what actually have you found? That I would like to tell you. See, you have found the position vector of these 3 points in space. Try to understand. What have you found? Suppose somewhere you have point A, somewhere you have point A here, okay? Somewhere you have point B, AB. So what have you found? You have found the position vector. See, you found A bar. This is A bar, okay? Then you found B bar, okay? And needless to say that this is 3D system. So, and you have found B bar. See, you have found B bar like this. You have found B bar. And also you have found C bar. Like you found A bar, B bar, you have also found C bar. You have found the vector C bar. You have found the vector C bar. C. So what you need to understand is this is your y-axis, this is x-axis, and this is z. What you need to understand that these three vectors are position vectors of points A, B, and C. Try to understand this. What are A bar, B bar, C bar? They are those vectors which give you the position of points A, B, C in space. These are vectors originating from the origin. This is A bar, this is B bar, this is C bar. Now what I will do? Now I shall find out the displacement vector. See, I will find out the vector. I will find out the vector AB bar. I will find out vector AB bar. Then I will find out vector BC bar or CB bar, whatever. Okay, I will find out vector BC bar or CB bar. Okay, so let me now do that. So here what I do is I will find out vector. Let me find out now vector AB bar. So here I write AB bar. I will write here AB bar equals to, as you all know, B bar minus A bar. What is AB bar equal to? B bar minus A bar. So you have this minus this. So 9 minus 3 I cap. 9 I cap minus 3 I cap is 6 I cap. 6 I cap plus 6 J cap minus 6 K cap. You understand? Minus 10, you are subtracting. So this all sign will change. So this will become positive 4K. So minus 10K plus 4K is minus 6K. You got AB bar. Okay, you write this as 1. After AB bar, I will find out BC bar. Okay, so let us find out vector BC bar. What will be BC bar? BC bar, I will get C bar minus B bar. C bar minus B bar. You got that? C bar minus B bar. So that gives me negative 11 I cap. Okay. Negative 11 J cap and plus 11 K cap. Okay. How plus? Because C bar minus B bar. So this minus this will become positive. And here I have BC bar. BC bar is 2. Now, after finding AB bar and BC bar, I noticed something very specific. I noticed something very specific. Now, what is that specific thing I noticed? I will tell you that. See, I noticed something very specific. And for that, what I will do is look at, I am noticing a relation between AB bar and BC bar. Now, what is that relation? You need to wait. I will show that to you. See here, AB bar, what I write is from 1, see, from 1, AB bar equals to, let me take negative 6 common. Okay, what I will do, or take, simply take 6 common. So if I take 6 common, see what I get. I get here I cap plus j cap minus k cap. Okay. Therefore, I get AB bar upon 6. AB bar upon 6 equals to I cap plus j cap minus k cap, and this is equation number 3. Okay. This is what I got from AB bar. Now what I do is from 2. Now let me work on 2. From 2 we get, see what am I going to get? I will take negative 11 common from this. Let me take negative 11 common from this. So here I get BC bar equals to negative 11 is out. So what I get? I get I cap plus j cap, I cap plus j cap minus k cap, because I'm taking negative 11 out. Now here you will notice, see, let me write this as 4. Now what I will write is, I will write using 4, I will write using 3 in 4. Okay, see here I have got the value of I cap plus j cap plus k cap. Here I have got the value of I cap plus j cap plus k cap. So I will write using 3 in 4 we get, using 3 in 4, 3 in 4 we get, see what we get. Where I have, I cap plus j cap minus k cap, I would be writing AB bar over 6. You got that? What would I be writing? I would be writing AB bar over 6. So I will get, therefore, check this. This is BC bar. I will write here BC bar equals to, BC bar is equal to negative 11, negative 11, and what is this? This is AB bar over 6. So negative 11 into AB bar over 6. So this gets me BC bar equals to negative 11 upon 6 AB bar. Okay, students, now what you see here, you need to interpret a result from this. Now see, what is that interpretation of the result? I would say that BC bar is a scalar multiple of AB bar. BC bar is a scalar multiple of AB bar. Now you should all understand BC bar is equal to minus 11 upon 6 times AB bar. It means BC bar is a scalar multiple of AB bar. So here I write, therefore BC bar is a scalar multiple, it is a scalar multiple of AB bar. Now we all know, if one vector is a scalar multiple of other vector, the two vectors are parallel. The two vectors are parallel. If one vector is a scalar multiple of other vector, then the two vectors are parallel. Therefore, BC bar is parallel to AB bar. BC bar is parallel to AB bar. Okay. Now, okay, and what does this negative sign shows? It shows that though BC bar and AB bar are parallel, but they have opposite direction. They have opposite direction. Nothing to be worried. Now see, for your explanation, what I will do is, let me draw BC bar. Think this is BC bar. Okay, this is BC bar. Okay, what I have to do next, I have to draw AB bar. See, I have got two vectors. Please understand, I have two vectors here, BC bar and AB bar, and they are parallel. This I have known. Why are they parallel? Because one vector is a scalar multiple of other vector. So I have drawn BC bar. It is time now I draw AB bar. Which vector do I draw? AB bar. And AB bar is in opposite direction. Okay, so I will draw AB bar which is in opposite direction. So I need to start. Okay, and one more thing, that I have to draw AB bar parallel. I have to draw AB bar parallel to BC bar. Okay, so see here, if I have to draw AB bar parallel to BC bar, try to understand. You know, I will have to go like this. See, a parallel vector to BC bar will always be this way. See, these two vectors are parallel. But try to understand, the vector which I have to draw, it is AB bar. That means the vector I am drawing has to have terminal point here, has to have terminal point here. And since it has to be parallel, it means it has to be this way. You understand? See, if I have a terminal point of a vector at B, if I have a terminal point of a vector at B, but I start somewhere else, so the vector which I get is no more parallel to BC bar. This vector is no more parallel to BC bar. I have to fulfill two conditions. One is what? The vector AB bar should be such that its terminal point is B, and further AB bar is parallel to BC bar. So you can check. AB bar has to be coinciding with BC bar. You see this? AB bar has to coincide with BC bar. See, this is AB bar. This is AB bar, and here you have BC bar. And what you notice? You notice that these three lie on same, they lie on same line, and hence the 3 points are collinear. So see, how do I write this? After having written BC bar is parallel to AB bar, I will write also point B is common. See, BC bar, you have B, AB bar, you have B. So what you will write? You will write also point B is common in both vectors. Now always remember, if you have two vectors parallel where one point is common in them, if you have two vectors parallel where one point is common in them, what will happen? The 3 points will be collinear points. Okay. Therefore, the 3 points A bar, sorry, points A, B, and C are collinear points. They are collinear points. I hope you have followed it. What now you can do is you can solve the second problem on your own. Okay, PQR. So what you can do is you can find PQ bar, then find QR bar, then you will definitely find some relation between them. Okay, please do that. Copy this problem and then solve the second one on your own. So we just solved a problem where we used the concept of scalar multiple of vector. Now, going ahead on the same concept, we have another question, that is number 12. See, what does it say? It says if the vector, which vector? 2i cap minus qj cap plus 3k cap, and another vector 4i cap minus 5j cap plus 6k cap are collinear, then find the value of q. What is q? Q is unknown. So we are given two vectors here, and we are said that these two vectors are collinear. It is given that these two vectors are collinear. So see, how do I begin? For solving the problem, I will first assume these two vectors to be a bar and b bar. Okay. So I write here, let a bar equals to first vector 2i cap minus qj cap plus 3k cap, and b bar as 4i cap minus 5j cap plus 6k cap. Then I will write, since a bar and b bar are collinear with each other or collinear to each other, that is one and the same proposition. So since a bar and b bar are collinear with each other or to each other, You can write it both the ways. Therefore, therefore, we can write. Now, what you can do is, since you have two vectors collinear to each other, you can write one vector as a scalar multiple of other vectors. So see here what I'm writing. I will write here A bar equals to M B bar. A bar equals to M B bar, where M is a scalar. What is M? M is a scalar. So now let me substitute A bar and B bar. So you will get therefore 2I cap minus QJ cap plus 3K cap equals to M times B bar. What is B bar? 4I cap minus 5J cap plus 6K cap. I multiply this M inside. Let me now multiply M inside. So you have 2I cap minus QJ cap plus 3K cap equals to 4M I cap minus 5M J cap plus 6M times K cap. Now let me equate the coefficients of I cap, J cap, K cap on two sides of the equation. Let me now equate the coefficients. Okay. So when I equate the coefficients, see what do I get. Let me now equate the coefficients. So here I have therefore, see, I equate the coefficients of I cap first. So on the right side, on the right hand side, I cap has the coefficient 4m, and here I have 2. So I can write therefore 4m equals to 2. That gives me m equals to 1 by 2. 2 by 4, that is 1 by 2. Okay. Then look at this. The coefficient of J cap is negative 5m. It is negative 5m, and here the coefficient is negative q. Negative q. So what would I write? I will write therefore negative 5m equals to negative q, and this m value we have already found. Okay, first of all, this negative sign will cancel. I will have 5m. It is 5 times 1 by 2 equals to q, and I got q value as 5 by 2. I hope you followed it. See how simple problem this is. Such simple problems you get. See, when you know the concepts, the thing is, the problems appear to be simple. You need to know the concepts. Okay, please do this. So here in another question, this is question number 10 from the same exercise. We are given the vector AB bar. Vector AB bar is given. The initial point of the vector, which is A, its coordinates are given, but the terminal point B coordinates are unknown, that we need to find. So what I understand from this question, I understand that the vector AB bar is given. I'm given the vector AB bar. This is point A. This is point A, whose coordinates are 1, 5, 0. Okay, whose coordinates are 1, 5, and 0. Then this is point B, whose coordinates are unknown. And we know the vector AB bar, that is 2I cap minus 4J cap plus 7K cap. Okay. So what I will do is, first I will assume, see, I will write let B be x1 comma y1 comma z1. Okay. And A they have already given. Okay. So here given A coordinates are 1, 5, and 0. So therefore, we can write what you can write. You can write here. See, I will write the coordinates of A bar. See, from point A, I will get the position vector of, from the coordinates of A, I will get the position vector of point A. And from the coordinates of B, I'll get the position vector of point B. So I'll get A bar equals to I cap plus 5j cap plus 0k cap. This is 0. No need to write 0k cap. And what is B bar? B bar I shall get x1 I cap plus y1 j cap plus z1 k cap. Okay, now I'm given AB bar. See, AB bar vector AB bar is already given. So I will write AB bar equals to, you know, by the definition of displacement vector, vector AB bar can be expressed as position vector of point B minus position vector of point A, that is B bar minus A bar. So you know that AB bar is also expressed this way. AB bar can also be written this way. Okay. So what I would do is, on the left, which is AB bar, I will write what AB bar is given as. So here I will write 2I cap minus 4J cap plus 7K cap. On the right, where I have B bar minus A bar, I would actually subtract A bar from B bar and I will write here. So B bar minus A bar. So what I have x1 minus 1 I cap. You see this x1 I cap minus I cap. So you take I cap common, you'll get x1 minus 1 I cap plus you will get here y1 minus 5 j cap plus z1 plus z1 k cap. Okay, z1 minus 0 k cap is z1 k cap. Now I shall be equating the coefficients. So here I will write here, therefore, see what you get. The coefficient of I cap on the right hand side is x1 minus 1 and on the left hand side it is 2. So what do you get? You get therefore x1 minus 1 equals to 2. x1 minus 1 equals to 2. This gives you x1 equals to 3. Similarly, you have y1 minus 5. You have y1 minus 5 equals to minus 4. See, y1 minus 5 equals to minus 4. So you have y1 equals to 1 and finally z1 equals to 7. Z1 equals to 7. Now you having obtained the value of x1, y1, z1, now you can write the coordinates of point B, whose coordinates you had assumed them to be x1, y1, z1. So we will write therefore B coordinates are 3, 1, 7. These are the coordinates of B. So question number 14 is express vector minus I cap minus 3J cap plus 4K cap as linear combination of the vectors, 2I cap plus J cap minus 4K cap, 2I cap minus J cap plus 3K cap and 3I cap plus J cap minus 2K cap. See, I have to express this vector as a linear combination of, I have to express this vector as a linear combination of the given other three vectors. Linear combination of given other three vectors. Okay. So before I take up the solution of this question, I would like to say something about the linear combination of vectors. Students, you already know what is scalar multiple of a vector. You already know what is scalar multiple of a vector. So for example here, see, if I write 5a bar, now you know 5a bar is 5 times of a bar. So 5 is a scalar and 5a bar is a scalar multiple of vector a bar. 5a bar is a scalar multiple of vector a bar. If I have 3b bar, so you know that b bar is some vector and 3b bar is a scalar multiple of b bar. Now if I add these two vectors, try to understand. If I add vector 5a bar plus 3b bar, this becomes linear combination of two vectors. What does this become? This become linear combination of two vectors. Linear combination of two vectors. This vector is 5a bar plus 3b bar. This is some other vector. This will be some other vector which will be in the same plane. It will also be in the same plane of a bar and b bar. Suppose I have one more vector, say I have one more vector which is say 7c bar, and I add this also. I add it or I subtract it, it hardly matters, you know, because say instead of writing plus 7c bar, I could have written minus 7c bar, and minus 7c bar is nothing but plus of minus 7 is nothing but plus of minus 7. So if I have one more vector, and if I have one more vector, say 7c bar, then this becomes the linear combination of, it becomes linear combination of three vectors. It becomes linear combination of three vectors, a bar, b bar and c bar. Now this becomes linear combination of, what I will call this I will call linear combination of three vectors. Now here what you need to understand is, that these three vectors where I notice 5a bar is a scalar multiple of a bar, 3b bar is a scalar multiple of b bar, 7c bar is also a scalar multiple of c bar. When these three vectors are added, they give me the linear combination of three vectors. They give me the linear combination of three vectors. And this will be some vector. This will definitely be some vector. And I write that as P bar. Okay, 5a bar plus 3b bar plus 7c bar will be some vector, and I write that vector as P bar. So now what I can say? I can say P bar, I can say here vector P bar has been expressed as a linear combination of vectors a bar, b bar and c bar. Now what we need to understand here is, what we need to understand that, see, in order to make you comfortable, I took the number as 5, 3 and 7. But in general, remember, it could be any number. It could be any real number, positive or negative. You understand? So I shall now be replacing these three real numbers as by x1, y1, z1. Okay, I could write them as x1, y1 and z1. Okay, or simply x1, or simply xy and z, or simply xy and z. So now what I have? I have P bar expressed as a linear combination of three vectors. P bar is expressed as a linear combination of three vectors, a bar, b bar and c bar. That is, P bar is equal to some real constant multiplied by a bar plus some real constant multiplied with b bar plus some other real constant multiplied with c bar. So we have to express this vector as a linear combination of these three vectors. Okay, I will write let there be three scalars x, y and z such that see, on the left I will write all alone this vector such that minus I cap minus 3j cap plus 4k cap equals to x times this vector plus y times second vector plus z times the third vector. And see what I have done. I have written this vector as a linear combination of other three vectors. So here the first vector x times 2I cap plus j cap minus 4k cap, y times 2I cap minus j cap plus 3k cap, and here 3I cap plus j cap minus 2k cap. Now I will multiply this inside. I'll multiply x, y, z inside. So next step I get is, see here, this will be 2x I cap, 2y I cap and 3z I cap. Got that? So I will write at once. Okay. So then I'll be taking I cap common from these three. When I do that, see what I get. I will get here 2x plus 2y plus 3z times I cap, then plus. When I multiply, see, this will get me x times j cap. So again, x minus, this will get me minus y times j cap, x minus y plus z times j cap. You understand? I'm multiplying x with j cap, y with minus j cap, and z with j cap. And then taking j cap common, inside the bracket, I'll get x minus y plus z. And here I will get minus 4x plus 3y minus 2z k cap. And on the right, what I have? I have minus I cap minus 3j cap minus I cap minus 3j cap plus 4k cap. Now what I do is, see, I will equate the coefficients. I will equate the coefficients. So see, this is coefficient of I cap on the right, and here I have equal to minus 1. Okay. So the next step I write is therefore 2x, I'll get here therefore 2x plus 2y plus 3z, 2x plus 2y plus 3z equals to negative 1. 2x plus 2y plus 3z is negative 1. X minus y plus z equals to negative 3, and minus 4x plus 3y minus 2z equals to 4. I can solve this problem using matrix method, that is reduction method. See, I have to, what I will do is I will write this I will write in the matrix equation form as follows. I'm using matrix to solve these three equations, okay, that we have done in matrices, that is reduction method. I will write the above three equations, can be written in matrix equation form as follows. See, what is that? That is here I will write, AB equals to C, this equation form. What is A here? A is 2, 2, 3. B is 1 minus 1 1, and what is, sorry, 2 2 3, and then 1 minus 1 1. I'm writing matrix A here. I'm writing first matrix A here, which is the matrix of coefficients of x y z. 1 minus 1 1, and then negative 4 3 and negative 2. Then I write matrix B. Matrix B will be a column matrix, that is x y z. And what is matrix C? C matrix is the right hand side matrix, that is negative 1, negative 3 and 4. Okay. Now we will write the transformation. See, I'm using the reduction method, and in reduction method what I will do is, check, see, first I will interchange, let me interchange R1 with R2, R1 with R2, let me interchange R1 with R2. So here you will get, so you'll get 1 minus 1 1, 2 2 3, minus 4 3, minus 2, xyz. Okay, I'm applying row transformation. So when you apply row transformation, no change on post factor matrix. The post factor matrix will remain as it is. Okay, only change in the pre-factor matrix and right hand side matrix. R1 interchange with R2. So here you have minus 3, minus 1 and 4. Now see this next. Now what I will do is I will write here R2 changes to R2 plus minus 1, R2 plus minus 2R1, minus 2R1, and R3 changes to R3 plus 4R1. What I'm going to do, I will multiply negative 2. I'm multiplying negative 2 in this and add to R2, and multiply positive 4 in this and add to R3. Why am I doing this? Because I want to get 0. I want to get 0 at this and this. I want to get 0 at this number, this position. Second row, first column, third row, first column. I want to get 0. And how do I get 0 there? How do I get 0? I get 0 with the help of this 1. So, you know, when I multiply negative 2, this will become negative 2, and add it, it will become 0. When I multiply 4 here, 4 into minus 4, 4 into 1 will be 4, and when I add it to negative 4, it will become 0. Okay, yeah. So I'm, with the help of R1, I'm getting the desired outcome in R2 and R3. So see, what do I get? I get here R1 as, see, R1 will not change. R1 will remain at 1 minus 1 1. R2 will change. How is it changing? Multiply minus 2 in all the elements of R1, multiply minus 2 R1 and add it to R2. You see this? So minus 2 you multiply. So add it 0, minus 2 you multiply. So it will become 2, and add it 4, minus 2 you multiply, add it 1. Okay. Then here R3 will change. Multiply 4 in all the elements of R1 and add it to R3. So now when you multiply 4, this will become 0. When you multiply 4, this will become minus 1. When you multiply 4, this will become 4. 4 plus minus 2 is 2. And here what you have? Here you have x, y, z. And remember, the transformation that you applied on the pre-factor matrix, the same will be applied on RHS matrix. So this remains same, minus 3. Now see, how is R2 changing? R2 plus minus 2 R1. Multiply minus 2. This will become 6. Add it. So 5. Multiply 4 here. So this will become negative 12. Add it. This is negative 8. Okay. Now you have to do, for reduction method, what we do, we convert this prefactor matrix into upper triangular matrix. Okay, so I just have to get 0 here. Okay, now see, how do I get 0 here? Since I notice that these two elements have become 0, so I will first, what I will do is I will make this 0 and then interchange the rows. Or I can do, I can first interchange R1 with R2 with R3, R2 with R3, and then get the 0 at desired place. So see here, what I'm now going to do is I will write interchanging R2 with R3. See, R2 interchanged with R3. I am interchanging R2 with R3. You see this? So R1 remains as it is, which is 1 minus 1, 1. R2 and R3 are interchanged. So here 0 minus 1, 2 will become R2. 0 minus 1, 2 will become R2. And 0, 4, 1 will be R3. 0, 4, 1 is R3. Okay. Then we have X, Y, Z here. We have X, Y, and Z. On the right side, what happens? On the right side, again, R2 interchange with R3. So negative 3, negative 8, and 5. Negative 3, negative 8, and 5. Now see, using this negative 1, I will make this as 0. So see, what do I write? I will write, see, this is diagonal elements. You got that? So I write here, R3 changes to R3 plus 4 times R2. I multiply 4 in the elements of R2 and then add it to R3. When you do that, you know what will happen? When you do this, this will become negative 4. You are multiplying 4. So this will become negative 4. When you add, you get the 0 at desired place. You got it? So here next you get is, see, R3 changes to R3 plus 4 R2. R1 doesn't change. 1 minus 1, 1. R2 doesn't change. 0 minus 1, 2. R3 changes. How does it change? R3 plus 4 R2. Multiply 4 here, so it will remain 0. Multiply 4 here, minus 4, it will remain 0. And multiply 4 here, so 8. 8 plus 1 is 9. 8 plus 1 is 9. Okay. There is no change in post factor matrix, which is XYZ, as it will remain as it is. Okay. We do not change the post factor matrix when we are performing row transformation. Now here minus 3 and minus 8 will remain as it is. See, how does R3 change? R3 changes as 4 R2 is added. So when you have 4 R2, this is negative 32. When you have 4 R2, when you multiply 4 here, this is negative 32. That negative 32, when you add to 5, okay, when you add negative 32 to 5, you get negative 27. Okay, what do you get? You get negative 27. So now we got the upper triangular matrix. So see, this is reduction method. In reduction method, the first step is you get the upper triangular matrix. See, below the diagonal, all the elements are 0. Now what I will do, I will multiply these two matrices. Now I shall multiply these two matrices. Let us multiply them. Now you know how to multiply. You multiply row to column. Okay. See, this matrix is having order 3 by 3, and this one has order 3 by 1. So when I will multiply these two, I will get the order 3 by 1. Okay, see, 3 is left here and 1 is, so 3 by 1. So let's multiply them. So see, I get here, see, 1 multiplied to x is x. I'm multiplying first row with first column. First row with first column, and whatever I will get, I will write in the first row and first column. So x minus y, minus 1 into y is minus y plus z. See, this is first row, first column. This is one single element, remember. Now there is no second column here. Try to understand. In this matrix, there is no second column, and hence the one that you are getting, it will not have second column. It will have just one column. Okay, next. Now see, 0 into x is 0, minus y plus 2z, and then finally 9z. Third row and first column is 9z. What do we have on the right side? Right side we have negative 3, minus 8, and negative 27. Okay, now I will equate these two matrices because they are equal. So since they are equal, I will have therefore x minus y plus z equals to -3. See, these two matrices have same order. So there, and they are equal. So their corresponding elements will be equal. So x minus y plus z is -3. This is equation number 1. Then minus y plus 2z is -8. This is equation number 2. And 9z, and then I have 9z. 9z equals to -27. This is equation number 3. So see, from 3 what I can get. This is all planned, you know. Why do we get 0 here like this? Because when we do this way, see, in the second row we got just 1 0. Okay. In the second row I got just 1 0, because of which, okay, because of which, see, I'm not getting x here. I'm getting y and z. In the third row, I got 2 zeros, because of which I'm not getting x and y. X is not there, y, only z is there. So what are we doing? By getting zeros, we are reducing the unknowns. And that is why, since we are reducing, that's why the name of the method is reduction method. So you have 9z equals to 27. So z is -3. After getting z here, we will put z in equation number 2. So see here. Therefore, equation 2 becomes what it will become? -y plus 2 into -3 equals to -8. Okay. So I get -y equals to -8 plus 6. So minus y is -2, y equals to 2. We got y as 2. Now using y and z in 1. Okay, using y and z in 1. Okay, why go on another page? Let me solve it here only. So I will write using y and z in equation 1, we get in equation 1. So see here, x minus y, that is x minus 2, plus z, that is -3, equals to -3. So we have x equals to 2. So x is 2, y is 2, and z is -3. So what I will do now here, I will substitute that. Okay, this I can write as equation A. This I can write as equation A. So I will write using x, y, z in equation A, we get using x, y, and z in equation A, we get. Okay, what we get? Now we have expressed the given vector. We have expressed the given vector as a linear combination of other three vectors. So what you will write? Minus I cap. So we will get here minus I cap minus 3j cap minus I cap minus 3j cap plus 4k cap equals to, now you have found x, y, z. So this is x times x, y, z. See, you will put x, y, and z value here. Here, you understand? Here. So you get here x times x is 2. So 2 times first vector plus y. What was y? Y is also 2 times. 2 times the second vector and minus 3. That is minus 3 times the third vector. You write those 3 vectors here and the answer is complete. See, you have expressed this vector as a linear combination of other 3 vectors. Don't forget to write these vectors, please. You have to write those 3 vectors here. Okay, I hope you followed it. Thank you very much.